Calculus video 79, some additional u substitution examples. So two more examples here. One, just because it never hurts to practice more u substitution, and just trying to give you a plethora of different functions where you might want to use u substitution. Okay, so we have one here, the integral from 1 to 5 of 4 minus 2x divided by x plus 3 dx. And once again, this is a fairly complex integral here. Not sure we wanted to just try to take the integral. A u substitution might work well here to simplify this before we take the integral. In this case, we would like to let u equal x plus 3. If you're not sure between like 4 minus 2x and x plus 3, choose the denominator. Alright, so du then is simply dx, so dx is du. The reason we would choose the denominator here is oftentimes we would like to, if we had like a monomial, right? So it's a completely separate example. When we had the integral of, say, 5x squared plus 2x plus 1 over 3x. One thing we would do here is we would take each term in the numerator divided by that denominator, because that denominator was a monomial. We would do the integral of 5x squared over 3x plus 2x over 3x plus 1 over 3x dx. And we learned this before u substitution, and that would then be equal to 5/3 x plus 2/3 plus 1 over 3x dx. And then what we could do, we could integrate those things individually, right? And we'd get, say, 5/3 x squared, actually that would become 5/6 x squared, plus 2/3 x plus 1/3 natural log absolute value of x plus c. And we could individually integrate each one. So when you see a problem over here like 4 minus 2x over x plus 3, the reason we like to let u equal the x plus 3 is if we replace x plus 3 with u, we now have a monomial in the denominator, and we can then often take whatever's in the numerator and divide it by that monomial denominator. Okay, let's try that. I do like to change my bounds. So bounds here, I had x equals 5. When I have u equal x plus 3, that would be u equals 5 plus 3, or 8. So x equals 5 went to u equals 8. And x equals 1, u is equal to 1 plus 3 is 4. So x equals 1 goes to u equals 4. And we get the integral from 4 to 8 of 4 minus 2x over u, letting x plus 3 equal u, and dx just becomes du. Okay, now we know we can't integrate here because I have both x's and u's, and I have u bounds, so everything needs to go in terms of u. And if that ever happens, we have an extra x or x squared left over, what you want to do is go back into that equation again. U is equal to x plus 3. And since I don't want to have the x's there, I'm going to solve for x in that equation. U equals x plus 3. Let's solve for x. Solving for x means that x is u minus 3, right? X is equal to u minus 3. If u is equal to x plus 3, x is equal to u minus 3. And then we're gonna substitute that in for the x here. And we get this. The integral from 4 to 8 of 4 minus 2 times x, but x is u minus 3, divided by u du. This would be the integral from 4 to 8 of 4 minus 2u plus 6 over u du. That would be the integral from 4 to 8 of 4 plus 6 is 10 minus 2u over u du. And you might be thinking that doesn't look any less complicated than the first one. But it is. And the reason it is because instead of having a denominator of x plus 3, I have a denominator of u. That's a monomial. That allows us to separate this. So this is 4 to 8, integral 4 to 8, of 10 over u minus 2u over u du. 2u over u, the u's cancel, so that's just 10 over u minus 2, and that we can integrate each individually. And so we get 10 over u, the integral there is 10 natural log absolute value of u, minus 2, the integral of 2 is minus 2u, evaluated from 4 to 8. And so we get 10 natural log of 8 minus 2 times 8, that's 16, minus, plug the 4 in, 10 natural log of 4 minus 2 times 4 is 8. So we get 10 natural log of 8 minus 16 minus 10 natural log of 4 plus 8. 10 natural log of 8 minus 10 natural log of 4 minus 8. Or just 10 natural log of 8 minus natural log of 4 minus 8. That would be 10 times, remember the properties of logarithms, natural log of 8 minus natural log of 4, that's the same thing as natural log of 8 over 4. So this would be 10 natural log of 2 minus 8, which is a perfectly fine answer. Or if you'd like, plug that into the calculator. 10 natural log of 2 minus 8, about negative 1.07, somewhere about there. And remember, it's okay to have a negative answer when we're looking at the area under the curve. So it's okay to have a negative answer. When we're looking at the area under the curve, it's really the signed area under the curve. I actually don't know what this graph looks like. But remember, if we're going, original function was 4 minus 2x over x plus 3 from 1 to 5. Here's 1, here's 5. What's happening more than likely is it's crossing the x-axis somewhere, right? And you're getting a little bit more area below the x-axis that you're getting above the x-axis, and so you're having more negative area than you are positive area. Therefore, you get a negative answer, and that's okay. Okay, very good. One more on this one. Let's try the integral from e, so number 2 here, e to e cubed of 3 over x natural log of x dx. Pause the video, try this one out, see if you can figure this one out. It is a u substitution problem, so let u equal something, and let's see if you can work through this one. Okay, let's see how you did. Again, when we're picking u's, we often pick a term whose derivative is also in the problem. So in this case, I'm thinking about letting u equal the natural log of x. The reason is, the derivative of natural log of x is 1 over x. And in the problem, I have a 3 over x. Okay, that's fine. That will probably end up canceling out because my derivative, 1 over x, will cancel out with the 3 over x. At least the x's will cancel. So then du is equal to 1 over x dx. Solving for dx means I'm multiplying both sides by x. So I get dx equals x times du. So again, I like to change my bounds. My x bounds, I have e cubed. For u, that would be the natural log of e cubed, which by properties of logarithms, that is just 3. Right, natural log of e to the third is just 3. And when x is just e, or e to the first, then I have u is equal to the natural log of e, which is just 1. And so my bounds go from 1 to 3 here. And so this is equal integral 1 to 3 of 3 over x. Natural log of x became u, and dx became x times du. And what we see is this x in the denominator cancels with that x in the numerator. I'm going to go ahead and pull the 3 out front. So this is 3 integral from 1 to 3 of 1 over u du. And no need to change it back to x's because I'm in terms of u here. My bounds are in terms of u. And so I get 3. The integral of 1 over u is natural log of the absolute value of u. Evaluate that from 1 to 3. That's 3. Natural log of 3 minus natural log of 1. Natural log of 1, remember that's 0. And so this answer is just 3 natural log of 3, which is a great answer. Or if you prefer the decimals, 3 natural log 3 is about 3.295, maybe 3.30. somewhere about right there. All right, so there's two more problems using U substitution just to kind of help us work and see more of these problems.